The last trig equation I'll be doing is cos squared beta minus sine 2 beta minus 1 is equal to 0. Again, the trick with these types of questions is identifying, okay, do I have a fundamental identity that I can identify anywhere? Do I have a double angle formula? So from this equation, we see that we do have a double angle formula and we do have a fundamental identity. What I would suggest with this type of question is, it's obviously going to be through trial and error that you finally get to the answer, but it takes practice, and for you to be able to finally be able to manipulate these questions, you need to ensure that you've picked the right identity or formula to use to plug into the question. So the first thing that I would do is look at the cos squared beta. I know that I can write cos squared beta as 1 minus sine squared beta, and the sine 2 beta, I can write it as minus 2 sine beta cos beta minus 1 is equal to 0. I wouldn't suggest that you change anything. The ones here, I wouldn't suggest you change those because you can see from this, these are like terms and they cancel out straight away. If you were then obviously to change them to the fundamental identities, you'll get the same answer, but it's just easier to just deal with the numbers as they are, cancel them out, because 1 minus 1 is equal to 0. So in the next line, what you're going to have now is the minus sine squared beta and the minus 2 sine beta cos beta being equal to 0. I can get rid of the negative signs by multiplying everything on the left hand side and the right hand side by negative 1. When I do that, I end up with sine squared beta plus 2 sine beta cos beta, and this is equal to 0. Right. Now, it's very important that at this stage you don't divide by any of your trig ratios, right? What you do is you treat it like a question where you're going to factorize, okay? So from this, I have two terms. From those two terms, what do you see that's common in the first term that's also present in the second term? Okay, I see that I have sine beta that's common in the first term as well as in the second term. What will I be left with in the brackets? I'll be left with sine beta plus 2 cos beta, and that's equal to 0. Now, we know that this is the type of question where you have A multiplied by B that's equal to 0. Therefore, your answer would be, it's either A is going to be equal to 0 or B is equal to 0. We learned this in grade 9, okay? So apply that here. Sine beta is equal to 0, or your sine beta plus 2 cos beta is equal to 0. Perfect. Now I can then work from there to find my general solutions. Let's take the sine beta that's equal to 0 and find the general solution for that. What are you going to do? You're going to say inverse sine both sides, okay? Inverse sine 0 plus n multiplied by 360. Okay, this time n is an integer. All right. Or b equals 180 degrees minus your inverse sine 0 plus n multiplied by 360, n being an integer. Okay. When I solve those, I get 0 plus 360 n, or 180, beta is equal to 180 degrees plus 360 n. Okay, n is your integer. Okay, so that's the first part. Now we still have to deal with this part of the equation. So you had sine beta plus 2 cos beta is equal to 0. Balancing method, okay, minus 2 cos beta is equal to your sine beta. I'm going to manipulate this so that I have my fundamental identity on the one side. So tan beta is therefore equal to your negative 2. Now I can use this to work out the general solution. Okay, inverse tan both sides. Beta equals inverse tan negative 2 plus n multiplied by 180 degrees. Okay, n is an integer. And I plug in inverse tan on my calculator. Again, your question was asking for one decimal place, so your answer would be minus 63.4 degrees plus 180, and n is an integer. Okay, so for this question, you have a general solution, okay, that will have your sines there, your sine, then you have your general solution that has your tan. Okay, so your three answers, that's the one. The other one is the 0 plus 360 degrees n is an integer, and the other one, 180 plus 360 degrees n is also an integer.